All right, so what you got?
You talking to me or somebody else?
Oh, no, I'm talking to you because you said you had a problem like this you wanted me to do.
Yeah, just could you like when we doing the word sentences?
Hmm.
When I couldn't. I think I put it in order. Could you tell me how I could go and probably practice how to put them in order and word them? What
Oh,
could
so
tell?
there wasn't one in particular that you wanted me to do.
No, I
Oh, okay.
need some refreshing. Where would I go back to get that information from?
All right, hold on. Let me see what section that was that you had a problem for me to knock out.
No, because it ain't really a problem. It's just me
Mhm.
knowing how to put being able to break the sentence down and put it in an equation.
Right, right. Let me see what section that was, though. Linear equations,
It was
33.
9-4, but we didn't have any homework on 9-4.
You said 9-4?
I thought.
Yeah, those the maybe you said that. I don't know if you said they weren't in there or they weren't going to be, but they're in there.
Okay, so now are you talking about problem solving or just writing it
Just writing it as an equation is
okay.
excellent.
Okay, so 9-4 is problem solving. So that's going the extra step. So now if you're talking about writing it as
Like it'll say the quotient of, and it'll give you the number times whatever. You know what I'm
right,
saying?
right,
Yeah.
right. Basically it's just asking for the expression, not necessarily asking for you to solve it. Right.
But 9-4 isn't on our homework, so I don't know if that's the right section.
Yeah, yeah. Yeah, 9-4 was actually solving the problem. This is what she's talking about is actually just telling you to set up the expression, but you
Oh,
don't have to solve anything. So let's see, equations, linear equations one, 6 decimals.
As far as which order it goes when you write the equation out. You understand what I'm saying?
I was just trying to figure out what section we're in so I can have
Okay.
a legit problems for you. Let's see. 3.3. Okay. All right. So are you talking about something like that?
Yes, probably. Yeah, something like that.
All right. Hold on.
And yeah, because it was more. I don't think I was having. It wasn't more or less the adding and subtracting. It was the division and the multiplication part of it.
Okay.
The quotient and the time when it says times the sum of -12 minus 4. You understand what I'm saying?
Mm-hmm.
Okay.
Quotient of 100.
Yeah, exactly.
All right, so the difference of -30 and 10 equals -40. Difference is subtraction. And so that's just -30 minus 10 is equal to -40. All right. Next one says the quotient of 100 and twice 50 is equal to 1. So quotient is division. And even with quotient, you would just write it in the order that you see it. So 100 divided by, well, let me write this. This one might be easier to write this way. 100 divided by, it says twice 50, so 2 times 50 equal to 100. I said 100 equal to 1, excuse me.
So it would actually let us put that in there as the answer?
Should.
Okay, all right.
Yep. Because they should have a button that has this option.
Oh, yeah, it does. I just didn't know it would let us put it in there like that. Okay.
Yep. All right, next one, the product of -5 and -29 gives 145. So product keyword there is multiplication, so it's -5 times -29 equal to 145.
Yeah, that's what I was getting wrong. Okay. Okay, thank you much, sir.
Not a problem at all.
And it's only a few of them, and it's like the very last part section. I was like, I'm almost done. I was like, I got to those and started getting it wrong. I was like, we ain't doing it.
All right. So, any questions before we look at exponents today? Everybody good? (12.1) exponents. Hold on, I wrote these notes somewhere already. Okay, there goes. There we go. I should have put 6.2 in there. Hold on. I don't know why I don't notate this stuff when I first do it. All right, so exponents is 12.1 for us. All right, so looking at exponents, if we have 2 to the third power, which is what we have right here, that regular size number 2 is your base, and then the number that's superscript up to the right is your exponent. So 2 to the third power and 3 to the second power are different numbers, two different values or two different evaluations. 2 to the third power is 2 times itself 3 times. 3 to the second power will be 3 times itself 2 times. And then you get 8 for 2 to the third power, and 3 to the second power would be 9. Mm-hmm. So one exercise could ask you to write by using your exponents. So if they give you 2x times itself 4 times, so that would just be 2x to the 4th power. All right. And they shouldn't ask you to do this yet because we haven't talked about exponential rules. So in this exercise, they probably just leave it like that. And we'll talk about, somebody must have asked me a question about this. So we'll talk about that in a second, but 2x raised to the 4th power will be how they want you to write it. All right. So when you look at this thing I was just pointing out here, if you have 2x parentheses raised to the 4th power, the exponent of 4 is applied to the 2 and the x. If you don't see parentheses, then that means that 4 of the exponent is only applied to the x. So you have to be careful with that. A lot of people make that mistake. You need parentheses in order for the exponent to be applied to multiple values.
Can
If
you say
not,
that? Sorry.
hmm?
Can you repeat that one more time?
Oh, it's right here.
Exponents of 4 is applied to the 2. Oh,
Yep.
exponents.
Because of the parentheses, the exponent, the 4, is applied to the 2 and the x. But if there aren't any parentheses, the exponent only applies to
Oh,
this
okay.
x, to what it's right up against.
Okay.
Mhm. Same thing down here, just re-emphasizing it with the x, y, and z. With the parentheses, everything is raised to the fifth power. That's inside of the parentheses. Um, but if there is no parentheses, the only thing that's affected by the fifth power is z.
The number closest to it.
Mm-hmm.
Okay.
All right.
2 more seconds, please.
Hmm.
I'm writing that.
Are you talking to me?
Yes.
What you said?
I said 2 more
Oh,
seconds.
okay.
I'm writing.
Not a problem.
Okay. Thank you.
Yeah, not a problem. All right. So here, it's emphasizing the same thing with those parentheses, except with negatives. So -4 squared. If there is no parentheses, then that square is only being applied to the 4. Then we see right here, using parentheses, the square is applied to the negative and the 4. So with that -4 squared without the parentheses, that's -4 times 4. That negative is still sitting on the outside, not affected by the square. So that will give us -16. Over here, with the negative inside of the parentheses, that's -4 times -4, which gives us +16. Because a negative times a negative is positive. All right. Then the next one down bottom, -4/5 cubed. That's -4/5 times -4/5 times -4/5. And two of those negatives will cancel out, leaving you with one negative left. So that still would be negative. But then 4 times 4 times 4 is 64. And then 5 times 5 times 5 is 125.
You know, math got a lot of rules you got to remember. Jeez.
I'm sorry.
It's like if you don't remember one thing, you get the whole thing wrong. I don't know what. Okay.
All right. This is just old stuff. Somebody must have, didn't mean to do that. Somebody during that class must have asked me a question about adding, subtracting fractions. So that's all that is. That has nothing to do with exponents. All right. So now let's look at our exponential rules.
See, I just told you all these rules.
I'm sorry. I didn't even think about it. I was about to give you some more. I'll let y'all write them down and then we'll talk about them. I believe I have 10 of them.
I need to make me some flashcards.
Hey, it couldn't hurt.
You ain't lying. I gotta remember all of this. Wait a
Well,
minute.
let's do this. That's 1 through 5.
It's
So,
wrong stuff. What is going on here?
all right, let's talk about it, and then we'll do the other 5. So, and then we're gonna do some examples, that, of course, that explain these rules. And once you put examples to them, you know, they do sit a little better. If you have the same base, I still have my eraser on. Okay. If you have x to the m times x to the n, in other words, if you have the same base and you're multiplying numbers, you're going to add the exponents. If you have the same base and you're dividing, then you're going to subtract your exponents. You know, so that's what the result was over here, adding and subtracting. Now, if you have we'll say two terms, two values raised to the same power, then you can apply that exponent to each one of them individually. Same thing with division. You can apply the exponent to each one of them individually. So that's why we had x to the m times y to the m. And then down here, x over m, x to the m over y to the m, you know, power. Like I said, we're going to put numbers on this thing. So the next 3, 5, 6, and 7 deal with negative exponents. If you have a negative exponent, in order to make it positive, you drop it down into your denominator. If you have a negative exponent in your denominator, in order to make it positive or write it as a positive, you bring it up to the numerator. Then if you have a fraction that has a negative exponent being applied to it, in order to make it positive, you can flip that fraction. And so now the exponent is positive. So you're going to have situations when you have a negative exponent as your result. And directions will tell you, make sure you write all answers with positive exponents. So that's where this would come into play.
Does it change the value?
No, no. Mm-mm. So if I had 5 to the negative second power, I can drop it down to the denominator and make it positive, and that'll be 1 over 25. Because 5 times 5 is 25.
5 times 5 is 25. Oh, okay, got it. My bad. That's
Okay.
the 5 to the second power.
Mm-hmm.
Okay.
Mm-hmm. And the next 3, and I had left off 10. 10 should have been earlier up on the list. And I didn't realize it until I got auto 10. I was like, man, I'm supposed to have 10 of these. So here, just if you raise a power to a power, then that means you multiply your powers. These are your general ones. Anything to the first power is itself. And then anything raised to 0 power is 1.
This last, the number 10 at the bottom, that means we distribute that exponent to the m and to the m and the n, right?
Well, this is raising a power to a power.
Uh-huh.
So I got x to the m raised to the nth power. So whenever you're raising a power to a power, that means you multiply your exponents. But the x is still raised to the multiplication of that power. So in other words, if I have x squared raised to the 3rd power, that's going to be x to the 6th power. Because you multiplied these two exponents.
Oh, okay. Mm-hmm. All right. Let me see. Hold on. Let me write this right quick.
Yeah. But we're going to do some examples that, like I said, emphasize each one of those rules.
Okay.
All right. Scroll up. Everybody good? Okay. So let's look at the first one. W to the 3rd power times w to the fourth power.
Excuse me, somebody knocked on the door.
So w to the third power times w to the fourth power. Like I said, you're going to add your exponents, and that'll be w to the seventh power. And so, when you look at why that works, is because if you were to expand w to the third power, that's www. Expand w to the fourth power, that's www. And so altogether, you have 7 w's. So that's the expansion and the foundation of all of these rules. If you were to expand it out
Yeah.
and do it the long way, then you would get, that answer. So those rules are just shortcuts in order to get to this answer right here. So all of those rules, 1 through 10, are just shortcuts, to get to the answer. So 2 to the 11th times 2 to the 8th, you just add your exponents. 11 plus 8, that's 2 to the 19th. So once again, notice that we have the same basis. 2 is our base here. The first one, W, is the base. If your bases are not the same, then of course these rules do not apply.
So on MATLAB, my MATLAB, will they want us to just leave it at that, or would they want us to simplify those exponents?
You're talking about 2 to the 19th? Something like 2 to the 19th, that's fine to leave. Now, if you had 2 squared or 2 to the third, something small, they would expect you to do. So if you had 2 to the 7th, normally that's small enough to still go because it's 128. But once you go higher than that, or if you have 3 to the 4th, because it depends. They wouldn't expect you to do 4 to the 7th because it's so much more larger. So if you ever have a question, if you put in the answer as an exponent and they want you to simplify it more, they would tell you. It will give you a hint. You know how when you write the wrong answer, to give you that little hint, it would actually tell you. So yeah, if you ever have any questions, just write it as the exponent, and then see what it tells you.
All right. It's just that you only get like 2-3 tries, I believe. And
Yeah.
marks it wrong.
Yeah.
Sometimes I already messed up a couple of times,
Gotcha. So normally, like I said, 2 to the 7th power is normally the highest that goes.
Yeah.
All the rest of them go to like the 4th, at the most 5th power. But the higher the number goes, the higher the base is, the least likely will they ask you to give the actual number. You know what I mean? Squares always, 9 squared, that's always going to be something to do. Cubes, I know second power, third power, fourth power will always be something that you can do. Once you start stepping to the 5th power, it gets a little sketchy. So yeah. Yeah, if you're talking about going to at least the 4th power, go ahead and evaluate that. Now, the number 2, though, you can take that all the way to the 7th, maybe even 8th power because it's such a small number. So 2 to the 7th power, like I said, is 128. So they would expect you to write that one.
All right. Thank you.
Yeah, no problem. All right, so the next one we have y to the y times y to the 9th times y to the 17th. Don't forget, when you don't see anything, remember that last rule is that they assume there's a 1 there. So there's 1 plus 9 plus 17, which is y to the 27th power.
That must have been what I missed when I went to answer the door. Okay, so let me ask you.
No, that was this one right, number 8.
Oh, okay. So it's
Yep.
just formula. Okay. All right.
Yep. Whenever you don't see anything, they assume that there's a 1 there for the exponent.
Okay. I thought I missed something.
Oh,
I
no.
got my notes though.
No. When you came back, I pretty much repeated it.
Okay.
Yep. Then the next one, a times b. Well, ab to the 5th power, a cubed b to the 8th power. So notice what we did here. Remember, this rule only applies to like bases. So if your bases are not alike, then you cannot add your exponents. So what we did was we put the a's together and then put the b's together. So a times a cubed, then b to the 5th times b to the 8th. Now then you can add your exponents. And remember, this is a 1. So 1 plus 3 give you a to the 4th, and then 5 plus 8 give you b to the 13th.
If you could forget to add that 1 as that exponent, they're going to mark it wrong, aren't they?
Yeah, because you would put 3, you know, so that would be wrong. Yep. So now, because, you know, adding the 1 right here is not that big a deal because that's just part of your scratch work.
Mm-hmm.
But recognizing, because like if I didn't put that 1 there, but just recognize 3 plus 1 to still give me 4, then I'm still going to get right as long as I put a 4 in my answer. But if you put a 3 in your answer, then of course that, you know, that's wrong.
Okay.
All right. Anybody holding on to these before we go to the next one? So in division, you know, with multiplication, we were adding our exponents. Division, we were subtracting our exponents. So this rule right here. So t to the 6th divided by t to the 4th. That means you subtract those exponents. 6 minus 4, t to the 2nd. All right. 5 to the 10th divided by 5 to the 8th. 10 minus 8 will give you 2 for your exponent, and then 5 squared is 25. So this goes back to what one of your classmates were mentioning about when do you evaluate something like 5 squared, they will expect you to write, you know, 25. So that second power is something they are expecting you to do. And then y to the 15th divided by y to the 8th. Must be in the next section. Y to the 15th divided by y to the 8th. It's 15 minus 8, which is 7. All right. Questions before we go to the next rule? Mm-hmm. Might not have to do all of these. Let me look at okay, so the next one, this was actually number 10. Remember I told you I forgot one and put it at the bottom. This was actually number 10 for us in that list that I gave you. But x to the m raised to the nth power means you're going to multiply your exponents. So if I have s and that was an s, I probably should have made that an x or something, but so it don't look like my 5, so jacked up 5. But that's s to the 4th raised to the 2nd power. So whenever you're raising a power to a power, then you're going to multiply your exponents. So it'll be 4 times 2, which is 8. All right. Same thing here. We have 3 to the 10th raised to the 5th power. 10 times 5 is 50. So it's 3 to the 50th power. Then the next one, we have x squared times x to the 5th raised to the 4th power. So what I did was simplify what was on the inside of the parentheses first. You know, whenever you multiply your variables, you can add the exponents. So 2 plus 5 gave me x to the 7th. And then 7 raised to the 4th power. That is like a 4. That's a little better. So then we have 7 raised to the 4th power. X to the 7th raised to the 4th power. 4 times 7 is 28.
So you said when you got two of the same exponents, you just could do the subtraction or the add, the addition or whatever.
Yep. So if you're multiplying, you add your exponents. And then if you are dividing, you would subtract the exponents.
Okay.
So if I had x to the 5th over x squared, then that would have been x to the 3rd power because 5 minus 2.
Okay. All right. Okay.
All right. The next one, let me erase some stuff though. All right. So the next rule, xy raised to the nth power. Making sure we got, yeah, okay, just make sure we're on track. So if I have negative 2xyz raised to the 4th power, that 4th power, probably gonna go purple, 4th power needs to be applied to each one of those terms. So that'd be negative 2 to the 4th power, x to the 4th power, y to the 4th power, and z to the 4th power. And then negative 2 to the 4th power is just negative 2 times itself 4 times. And that gives us a positive 16. So that'd be 16 x to the 4th, y to the 4th, z to the 4th. All right. Next one, similar situation. We have 5x squared y to the 7th, and that raised to the 3rd power. And that 3rd power or cube needs to be applied to each piece. So that's 5 cubed, x squared cubed, y to the 7th cubed. And 5 cubed is 5 times 5 times 5, which is 125. X squared to the 3rd power, 2 times 3 for your exponents. Remember, a power to a power means you need to multiply. So that's why we have x to the 6th. Same thing here. Y to the 7th raised to the 3rd power will be y to the 21st. All right, questions? All right. Same thing goes with division. When we look at x over y raised to the nth power, you apply that m to the numerator and denominator. So when I look at 2 over 5 raised to the 3rd power, that cube needs to be applied to the top and bottom. So that's 2 cubed over 5 cubed, which is 8 over 125. 2 times 2 times 2, and 5 times 5 times 5. Mhm. Questions? Any questions? And some of this stuff, it's better to make sure we understand that the best way to attack this type of problem, these type of situations, is that you have to get your practice in. You don't want to come from the standpoint of let me memorize these formulas or memorize these relationships. Really, the way you come into it, the way you should come into it is by thinking, I need to get enough practice in so that I'm not doing this off of memorization, but just I'm reacting to what I see, reacting to the symbols that I see. So you do want to get enough practice in so you're not trying to remember Rule 10 of the exponent rules or Rule 5. It's just that, the more you do it, the more practice you put in, the less it's about memorization. It's just about reacting to the symbols that you see. So it will take some time and some practice, especially if you haven't seen these in a while or you haven't seen them before, period. It's going to take some time to get yourself, acclimated to what they're presenting to you. So we have 2x cubed over y to the fifth. So this squared, needs to be applied to everything in the numerator and everything in the denominator. So that's why we have 2 squared times x cubed squared over y to the fifth squared. Two squared is 4. And then x cubed squared, remember once again, a power to a power, you multiply the exponents. 3 times 2 is 6. And y to the fifth squared multiplies the exponents is y to the 10th. All right. So let's look at simplifying this expression. Got a couple of these. Yep. Let's look at simplifying some expressions. Just basically using the rules now. From what I see, they don't have any problems with negative exponents. So you probably lucked out with that. Don't have to worry about that rule with the negative exponents. But let's look at the ones we do have. X to the second raised to the sixth power times x to the third power over x to the seventh raised to the second power. So the first thing we recognize is that we have powers being raised to another power. So we need to multiply those exponents. So 6 times 2 gives you 12. And then down bottom, 7 times 2 gives you 14. All right. Any questions on that part? So now we have x to the 12th times x to the third power in the numerator. So we can add those exponents as multiplication, add those exponents, and that'll give us x to the 15th. So remember, when you multiply your variables, you add your exponents. And now we have x to the 15th over x to the 14th. We're dividing our variables. 15 minus 14 will give you 1. So our answer is just x. And I'm pretty sure if you put x to the first power in there, they'll probably give you another hint saying that they want the answer in its most simplest form, which would just be x. So, all right. Questions on that one? All right. So here we have 3cd squared. Notice that square is only applied to the d. Then we have 2cd cubed. So we have a cube out here. Oh, still have my eraser on, sorry. We have a cube out here that needs to be applied to each piece that's inside of the parentheses. And that's what I did right here. So notice 3cd squared is still the same. Nothing's changed on that. But then I have 2 cubed, c cubed, and then d cubed. All right. power to a power is right here, so I need to multiply. So you see I have d to the 9th. So we got 3cd squared, that comes from the first parentheses, times 8, because, 2 cubed, 2 times itself 3 times will give you 8. C cubed, and then d to the 9th. So now we're going to multiply together the like bases. So 3 times 8, just regular numbers, so you go ahead and multiply those together. C times c cubed, d squared times d to the 9th. And that'll be answered, 24 c to the 4th, d to the 11th. All right, questions? Any questions?
I think so.
You say you think you have a question, or you don't think so?
I think I have a question.
All right.
So I think I'm getting confused. 3 and so 8 times the 3. Where'd you get the 8 from?
We had 2 cubed right here, so that's gonna be 2 times 2 times 2.
Oh,
Okay.
I was trying. It was all these 2s that I was getting a little confused.
Yeah, it's all good.
I think that the way I'm writing it down is confusing myself. That's all.
Mhm.
Oh, I see how you did it. Okay.
All right. Are we good?
Yeah.
Okay. All right. So here we're just emphasizing the zero exponent, anything to the 0 power is 1. So erase all. Yeah, that's fine. So 4 to the 0 power is 1. -4 with parentheses to the 0 power is 1. But remember, I mentioned before, if you do not use parentheses, like in this one down here, the 0 is only being applied to the 4. So that's going to be -1. That negative that's sitting out there is the same negative in your final answer. Once again, the 0 is only being applied to the 4 and not the negative. So the answer is -1. X to the 0 power is 1. And then here, -4 times x to the 0 power. Once again, no parentheses. So the only thing to be affected by that 0 is x. So that's why the -4 is still out there. -4 times 1 is just -4. And then here, because I do have parentheses, everything's being affected. That's in that parentheses by the 0. And that's why the whole answer is 1. So make sure you pay attention to the parentheses. And if you don't have parentheses, the number that's right up against the exponent is the only one that's being affected, number or letter. All right, questions? All right. 0. Don't worry about negative exponents right yet. Don't write that down. Let me confirm. Looking back in this section, make sure you guys don't have any negative exponents. Because if you don't, then I won't force it on you. And this goes into polynomials. So last section, they did have negative exponents. So adding and subtracting polynomials, that's 12, 2. All right. What time is it? 10:30. You guys get out of class at, I can let that be it for today. So now, next class, we're going to get into polynomials. Don't let me forget to start right here for next class for polynomials. Yep, that's going to be the start. That's going to be 12.2 for us. Once again, I didn't see any negative exponents. So you guys are good on that front. So we won't go over that. But we're going to start here with polynomials on next class.
All right.
Questions, concerns, comments before we leave today?
No.
All right. So you guys have a good one. Have a great weekend. Be safe. And I will see you on Tuesday.
All right, then. Thank you.
All right, no problem. Take care.
Bye-bye.